These are your PowerPoint notes on our next concept of density, which is going to be a classroom topic and a laboratory topic. These are considered exactly like classroom notes and need to be put in your notebook. Density is a topic that many of you will remember from earth science or possibly from math or previous science classes. Density is defined as the amount of matter present in a given volume of substance. You can see what we call a density column over at the right. So your heavier items like the honey is going to be on the bottom, and your less dense item, the vegetable oil, will be up on top. So density is a physical property that we highlighted for our first laboratory. The measurements we're going to use in lab and classroom for our density is going to be in grams per milliliter, is how that is read, G-ml, again, grams per milliliter. One important thing that you need to know and have memorized is the density of water. The density of water is 1.0 gram per milliliter. Here's the density formula we'll be using in class. Density equals mass divided by volume. And one question to think about, if you had a can of regular Coke and a can of Diet Coke and put them both in water, are they the same density? Will one float? Will one not float? And again, density, your labels are grams per milliliter. Your mass will be in grams, and your volume will be in milliliters. Here's a sample problem. Okay, there's our equation, and here's the sample problem. If an item has a mass of 25.0 grams and a volume of 34.2 mils, what's the density? This is our first problem solving in class. Everything that you do problem solving in class, you must show your work. So the way you show your work, you write D equals. The mass is 25.0 grams. Keep the 0 in there, that's important. Your volume is 34.2 mils. And then your mass divided by your volume, that's where your label comes from. Just like in math, our numerators and denominators, if they don't cancel, we keep them both. So the number is 0.731, and the label is grams per mil. Notice how many digits I'm using. There's 3 digits in each of these, so I answer in 3 digits. Those are called significant figures, what we'll be abbreviating as sig figs. So again, 3 in each of the questions, and so we give 3 in the answer. Here is sample number 2. Again, here's your equation, and here's your question. If an item has a volume of 3.42 milliliters and a density of 5.56 grams per mil, what's the mass? Now, the way you show this, you plug each variable in as the equation sits. So you write the density, 5.56 grams per mil, including the label, equals x over 3.42 mils. To show your work in class, you set up the equation, and then doing the math is up to you. So this is what you show. So when I say show your work, this is what I need to see when I say show your work. Then you plug it in, you do the math, and the math tells you 19.0 grams. Again, looking at what we call sig figs. We have 3 significant figures in each parts of the question. We have 3 digits in the answer. The 0 after the decimal point counts. Last problem then. Here's your equation. Here's the question. And this time you are going to go ahead and set that up in your notes, and you're going to go ahead and get the answer. Show all the work in your notebook and record that answer. So we're going to be using this information to figure out, will something float on water, and what will its density be? So for example, if the duck is floating on water, is the density greater or less than water? And so in this case, it would be less than water. Water has a density of 1.0 gram per mil. So the little rubber ducky has a density of less than 1.0 gram per mil. What you need to do to get credit for this assignment is not only put these notes in your PowerPoint, but also click on the Google Doc link below and fill out that form. And this is due Tuesday when you come into class.